Howdy everybody in YouTube land. What we have in front of us today are a pair of Macintosh Portable chargers, AC adapters. Now, these are 7.5 volt, 1.5 amp, and they're that voltage or current requirement on purpose to make sure the 6 volt battery charge is proper. The Macintosh Portable is not designed to run off the AC adapter. It's designed to continuously run off the battery while this floats and charges the battery. That's all it's designed for. Moving along, so they look the same, but they are not. And that's why I've got two of them in this video, because I want to go and show you that there are differences between the two power supplies, besides one being more yellow than the other. They're both portable, but notice the labels are slightly different. If you enhance, this one is a CR-76U, which is Sony. This one, on the other hand, is an SMP-10BB, which I think is either Aztec or Delta. It might be Delta. I'm not sure. Now, can you guess which one works and which one doesn't? This one works. This one doesn't. Now, there is a couple of differences here. Like this one has M5126 in the model number. This one just M5120. And then the 0715 is the charger, the external charger. But yeah, this one's rated to run the 5126, but the current requirements are exactly the same. So, this one's just newer. Anyways, so this one does not work. This one does work, but we're going to go ahead and take both of them apart because I don't know about this one, but I know this one has got capacitor goo that just gets all over the place. So now there's a question of how you get these apart because these are sealed. Well, there's multiple ways. You can use a bench vise, you can use clamps. What I generally do is I need two tools to crack these apart. I need this tool, and for better or for worse, I need that tool. And so we take this tool, we beat the crap out. No, I'm just kidding. So no, on this plug, there's a strain relief right there. You can fit that flat blade screwdriver in between here and just give that screwdriver just one little whack and it will snap this whole thing apart. And the damage in the plastic is practically not visible because it's covered by this rubber plug. So that's how we're going to get these apart. So I'm going to start with this one because this one is the one that's worst off. And this one needs new caps and all that stuff. And you'll see that here in a minute. Unfortunately, with the amount of yellowing, probably heat related, I've tried my clamps, I've tried my hammer, I've tried my flat blade screwdriver, my tool. This thing will not crack apart. And these are normally easier than that. But this one's also extremely yellow, like it's heat soaked. So I'm wondering if it's just got the plastic that much harder. But it will not crack apart. So I'm going to have to go locate a vise and see if we can try that. Because none of my other tools are working. Well, after about an hour and a half later, driving and browsing a store, because everything in this town is miles and miles away, because I'm in the middle of nowhere, but beside the point, I grabbed the pencils and this little tiny bench vise to try to crack this apart, because this is how you're supposed to do it, but it is just being incredibly stubborn. It just will not go because I'm afraid of busting the plastic, so I have to be careful. Yeah, this sucker would, even with the vise, would just absolutely not crack apart. I had to, while clamping it with a vise, I had to use the screwdriver to get in here, and you can see where I had to mark it really badly. Yeah, I had to use a screwdriver to get in there and pry on it while it's being squeezed. And it finally snapped apart, but this thing was glued shut hardcore. Unlike some of the ones I've worked on before, this one is like really hard to... Oh, man. Anyways, now that we got it out, we can take a look and see how bad this thing is leaking. So also it's got this hot glue everywhere, and the screw we have to get to is where that red capacitor is. You can't get to it with all this crap in the way, so we're gonna have to pry all that out of there. Well, let me tell you, I just pulled the screw out. I had to use the heat gun and work this hot glue out a little bit. Just pulled the screw out, and look how nasty that screw is. So I'm afraid of what I'm gonna find in there. What I do want to do is move this other charger out of the way because I don't need it there. Turn on the soldering irons because we're gonna need those. And I'm afraid of what I'm gonna find under here because I haven't pulled this out yet. Oh man, look at that. That's disgusting. Wow. Just, wow, this stench. It's like a hot day in a fish factory. It's terrible. Oh, pretty. Look at the color shade difference. Alright, so a couple things I want to note here. And I've confirmed this with other people that are having problems with this particular version of the power supply, and that is, even when you recap it, sometimes the power supply won't regulate at all, or won't start, or becomes erratic. And what it is, it's this, you see that hybrid IC right there? The CR-76D? That is made out of an epoxy that has the same problem that the Sony Walkmans do. That this epoxy absorbs moisture, and it starts to go conductive. And when it does, we start getting little malfunctions in the chip. So we need to remove all of this stuff, and we've got to come up with a solution for that. And I'll show you what that is in a minute. So the first thing we have to do is get all this hot glue off of here, take this thing all the way apart, and recap this power supply. And this power supply is absolutely disgusting. So in order to recap this power supply, we have to strip it all down. And when we strip it all down, I typically see, this one's not that bad, but it's bad enough to where I grind down all of this off and re-tin all the copper because it gets really, really nasty. So, anyway, so I got to get all this hot glue off of here. And what I typically do is I just pick away at it until it comes off. Sometimes I have to soften it up, but a lot of times I don't. And the reason why you want to get this off is because you can see the color shift here, because this is absorbed cap goo. So all that's got to come off to get all that off of there, but also it will free up this so you can remove this little shroud. And it'll allow you to get to everything. You got to get these two blobs off too so you can get this daughter card off. Once I have all this stuff out of the way, the next thing I do is I start stripping down all of the parts on this board on this side of the power supply. I'll pull the transformer too so I can clean the pins up underneath, but generally this side of the board is completely stripped down because what I want to do is I want to grind all this stuff off. Wash the board, get it clean, and then grind all of that off because you're going to have a hard time cutting through this solder and it's just disgusting. So, step one, let's just remove all the parts out of the way. Pretty much like that. So all the components have been removed off the board, and you got some cap goo and stuff here. So I'm going to go wash this board real quick. And once I wash this board, we're going to get in here and grind down all of that copper solder mask, all of the oxidized solder that won't, it's pretty disgusting. So we have to grind all of that down to know if there's any breaks and also to prevent further corrosion. So we will get that taken care of next. Got it nice and clean and washed off. So now comes the fun part. Cleaning all this off. It's going to be fun. Wow, this is the most time-consuming part right here, and I'm on my second set of batteries, but that's the next part you have to do is clean all that off and re-tin all of that copper. Alright, and there we go. It's all tinned up and ready for components. So this diode right here, which goes right there, is just your general purpose, high speed, fast recovery switching rectifier. And I just throw like a 5817, 5819, whatever. It's a little bit bigger than that, but it will fit in there. And that's what we're going to do. Because usually this gets drenched by capacitor goo. And in this case, I didn't see it on this one because this particular cap didn't leak. However, this one kind of started to, but this one really did. So regardless, I change it anyways, and I just take this engraver tool and clean up the pins and stuff off of those, and I'll reinstall those back in there along with a new diode, and that's it for this board. So that should take care of this board. Then we need to move on to this one. With that out of the way, all the parts are back in here with the exception of the daughter card. We need to move on to this board here. Now, unfortunately, we have to deal with this chip here, the CR-76D SHIN EI, or however you say that. It's just a epoxy encapsulated hybrid IC. Now, there's a couple ways you can deal with this. The first way you can deal with it is you can take this off the board and stick it in acetone. It'll take a good 24 to 36 hours to fully soften up, and you can pick this apart. Sometimes you have to do it 2 or 3 times in a row, and I will insert pictures right here in the video showing that process where I've already done one of these. But however, there's a second option. And the second option is what I really wanted to do in this video is we can simply replace this IC. Well, how are we going to do that? How are we going to replace the IC? Well, here's how. I went ahead and made these little guys. So what I did was I reverse engineered this IC and I decided to reproduce it in a circuit board. So you have two options now. You can either depot this IC and hope it's still good, or just replace it with a new one. Now, I've not tested this yet, and that's one of the reasons why I decided to take this power supply apart, is so I can actually test this. Now, like I said, there's issues with this supply where there could be voltages swinging wildly, or there's a problem with the thing not starting at all, or what have you. So I decided to reverse engineer that, and we now have a bag of parts. Now, I only ordered enough parts to build one of those. I did it on purpose. In case I let the magic smoke out, or I made a mistake or something like that, I can, I can write it off. So, and then go back to the original one. But I'm hoping that I didn't make any errors in the PCB design. So, and again, I'll insert in this video what this module looks like depotted, which shows the film resistors that are printed on the board and stuff like that. So I did some measurements of the capacitors on here, and we have the thing made. Now, I will say this. All of the semiconductors are still original and available, with the exception of the 2 Zener diodes. So I had to substitute that with a newer version, but otherwise everything else is pretty much the same. So we can assemble this. Now, unfortunately, there was not enough room on this circuit board to put the silk screen on here with the part numbers and all of that. So I have to look in the schematic to figure out where they all go. I mean, you got to understand the sheer size of this thing. Here's an American penny, for example. It's tiny. So it's going to be fun to assemble. But you know what? We should video the assembly process of this, I think. Alright, now that we're assembled, I have this cute little module right here all put together. So hopefully I have no mistakes in the design. That will go in there. And in theory, this power supply should run. That thing just barely clears. I made it like where it was just right. Just barely makes it. Not even a millimeter to spare. That's cool. Hopefully this wasn't all in vain and that this works. Now, because I don't trust this thing, I'm probably going to plug it into the light bulb. So if this thing explodes into a ball of flames, it'll just short and make the light bulb glow bright. Alright, well, because I don't trust this thing at all, we're going to plug it into this light bulb. Now, sometimes this is not a good thing for switching power supplies, but anyways, well, it plugged in and didn't blow up, and the light bulb didn't popificate. So, do we have voltage? Well, let's see. I don't know if we do or not. No. No, it didn't work. Actually, never mind. I just didn't have a good connection on it. Now that I got a good connection on it, look, it's working. Wow, I'm impressed. So there we go. We actually have a solution for this IC now. Now that will be available on my GitHub. So if anybody wants to make those, you can go on my GitHub and get the project and download it. Now, I think the parts were only like $4 plus the circuit board from PCBWay was like $25 for 20 PCBs. So I've got a bunch of these circuit boards. But anyways, so there's your two options for the Sony version of this power supply. You can either depot this one or you can make a new one. So in this case, I chose to make a new one and it works perfectly fine. So we got to clean the case up and put this thing back together. But in the meantime, we should move on to the next one that needs a bit of work, which is the Delta version. Now with this Sony one fully working properly, I went ahead and glued it back together to get it out of my way. And it was much easier to do, just like the first one I did was. For some reason, this one was so much more difficult, but I decided to go ahead and split apart this Delta version so we can take a look inside of that one. And yeah, it's very, very different inside here. It is nowhere near the same design. It looks like it's using a similar daughter card topology, and it has a IC in there instead of it being all transistorized like this one is. We have a different set of caps, and the reason why it's still working is I don't see any leakage. So when this thing was made, it's possible when they made this thing, they didn't use any low ESR capacitors, and that's probably why they're still good. See, what do we have? We have a pair of 1000 microfarad at 16 volt. We have I don't know, we've got some other stuff in there. And we got some screws that have backed out too that we need to get out. So let's get this thing taken apart and get a closer look. Alright, there was only the one screw holding it in. I tell you, it was almost backed all the way out. Probably from thermal expansion and contraction. My worry would have been that would fall completely out, fall on something and short it out, which would be really bad. So one thing I noticed with this design is the voltage control is right here, but unlike the Sony, this doesn't have an individual current set point. So you can't adjust the current rating. It's fixed, whatever it is. It's probably trimmed off by like some resistors down here or something. And what in the blobular is that? Bodge. Oh boy. Anyways. Oh yeah, this thing is much cleaner than the Sony. At least, you know, I can work with this one. So let's see. Are these 1000 microfarad caps leaking? I don't know. Let's see here. I think... yeah. Let's see, I'll hear it sizzle. This thing's plugged again. Yeah, I need to get like a Metcal or something, but those are so expensive. Maybe when I'm rich someday. Anyways. Let's see, do we have any signs of leakage? No, we do not. I see no evidence. So these, what are these? These are KME series. Whatever that is, that's a good one. That's a good series. Because I am not seeing any evidence of leakage. Now, the next question is, this is probably why the power supply still works perfectly fine without failure. I don't know why, but it's not wanting to come out. Yeah. Yep, I gotta clean that. It's plugged. It usually makes a funky sound when it does, so. Alright, I need both hands for this. Alright, so with this particular power supply, we have two 1000s at 16. And the reason why it didn't come out is because it had this glue on there. So we have two 1000s at 16. We have a 100 microfarad at 25, which goes here. And then we have a 10 microfarad at 50 volt. And then over here we have a 4.7 microfarad at 50 volt. Tacon is not a brand I'm familiar with. I don't see any signs of leakage, but we're going to go ahead and change those out. I very, very rarely ever change these. I've only encountered maybe one or two of these types of caps that's ever leaked. So I don't bother with those. Unless they're dried out, baked, or shown signs of heat stress, I don't bother with those. I leave them alone. So anyways, we're going to go ahead and get all these caps out, and we're going to change them. I don't know if I have anything small enough that will fit within these dimensions. I'll have to check my stash. Yeah, that explains a lot. So, the KME series is our standard general purpose capacitors. So these are not Louis SR. That makes a lot of sense why they're not leaking. It's usually the Louis SR ones that leak. I'm going to change them anyways because of just how old they are, but just keep in mind that when you replace these, to use standard capacitors and not Louis SR caps. Because the power supply was designed with standard capacitors in mind, so changing the impedance of the capacitor network could affect the stability of the power supply. Not all power supplies are like that. In a lot of cases, you can get away with using the stuff interchangeably, but not always. The Apple II is one of those power supplies, for example, that you cannot substitute standard with low ESR and vice versa. The power supply will not run properly. So just FYI. So I'm going to put in there what came out of there. Alright, so I went through my stash, and I do have two types of standard. So this is the 1000 mic 25 volt VR series. Those are not low ESR, they're standard. These are also standard. They're 1200 though, and they're good for 9,000 hours. I'm considering using those. But if all else fails there, we have these 1000s at 16, which are low profile, and they're also general purpose standard electrolytics. And of course, all these red ones are standard. None of those are low ESR. So I think we'll be good. I have my choice. I'll probably settle with these because these look close to the original ones. About the same height, really. Very, very close. So we'll just use these because I have them and I'm getting low on these anyways. The only thing I don't like about these is how short the lead lengths are, but it's fine. We'll use those and we'll get this guy fixed and going. we go. We are perfectly recapped. Well, with the exception of this one, but again, that one doesn't matter so much. But all the other new capacitors are installed, so we're going to go ahead and get this guy back together. Now, why am I not testing it before I close it back up? Well, I'm fairly confident it's going to work fine because it worked fine before. So we're just going to zip this back up, plug it in, and we're going to test the voltage and make sure that everything is good, which I'm sure it will be. This was all recapped and put back together. Can't even tell I cracked it apart. So this guy here should be good to go. I'm going to plug it in and test it and make sure, because none of them were leaking. Different series, general purpose. That's why they weren't leaking. But better be safe than sorry. We're plugged in. I'm holding my fingers on it. And there we go. It works fine. Voltage is a slightly bit high, but honestly, that's not bad. It's close enough. So that charger works perfectly fine. So there we go. The Delta's all recapped. So that's it. Both chargers are recapped. The only thing left to do now is to plug these in the Macintosh Portable and get them tested and see if they work. Now, this one I know did, so I'm not worried about that one so much. This is the one that we had to rebuild the hybrid IC on and all of that work. And I'm more concerned about the load stability over time with this guy here. It's probably going to be okay if I were to hazard a guess. But who knows for sure. So let's go ahead and get this thing plugged into my Macintosh Portable and do it under test. Well, unfortunately, I was going to test it through my little charger setup rig here, but both of these batteries are shot now. Not surprised. I mean, they are 11 years old. That one was rebuilt by a friend of mine, and this one was rebuilt by NiCad lady. But point is, no good. So, off to the junk heap those go. I actually have one that still takes a charge. I have three portable, well, three. Imagine that being three. So I have three portables. This one has one of those black 6-volt like emergency lighting batteries. That one still charges. These two have the Cyclone cells, and they're junk. So at least we know what the lifetime of these cells actually are. So we get about 10 years out of them, give or take. So there we go. That one's charging. We'll plug in. I got a portable that has a battery eliminator in it, and should be good. I'll try that out. But hey, it's working on the Sony charger. We're charging the battery. Alright, so we're still plugged in. Now, this is a backlit Macintosh Portable. It does not have the main battery, and it's got a battery eliminator installed in here. Now, keep in mind, a 1.5 amp charger is not enough to fully run this thing consistently, because this thing draws so much power that it will eventually suck dry those super caps and kill that adapter, unless the power is reduced and you're doing light load. As long as the load is light, it'll hold up. Otherwise, it won't. That's why having a battery is so critical. Like, for example, if this battery was in here, it would primarily run off that battery during the high usage times. And then if the machine is asleep or in standby, or the screen goes black and you do like a low power usage mode type thing, it will charge the battery. Or if it's turned off, it'll charge the battery. Anyways, let's fire it up. Seems to be working fine. It's been plugged in that charger for a few hours, and it's running off of here. This is getting warm. So, doesn't look like it's going to hold. No. No, siree, Bob. Nope. It is not working. Not working off of this guy. It just does not have enough current. No, it just doesn't. Yeah, it's not supposed to run off this. You have to plug it into this in the battery eliminator. Okay. Likes that better, I guess? It's running. Yeah, you're not supposed to run these without the battery on the anyways. That's being charged up by it and it's referenced. So the super caps are acting as a battery. It's working. So it is working off of that charger. So that's good. It's running at least. So the charger is stable. It's just the battery eliminator doesn't like the portable as much. So let me grab my charger, which is a known good charger. Plug that in, which is the one I just recapped, by the way. Let's grab you, plug you in. Okay. Maybe. Nope. It's actually kind of impressive, though, how much you'll run off the super caps, because watch. There it goes. Now it's shut off. Plug you back in. Dare I plug two in at one time? I don't think that's a good idea. Although that would be an interesting thing. So 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. Then it shut off after 5 seconds. So let's plug in the Sony. So the Sony charger is plugged in right now. We know it will run off the Sony charger if it's plugged in here. Or not. So this thing is not putting out nearly enough current. I'm going to have to do a current load test on that to make sure I can hit 1.5 amps. Because if I'm not able to hit 1.5 amps, that would explain exactly what's going on here. It's on. Let's see. 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. Yeah, it's about the same. So it is working. I don't know. It's weird. Anyways, what I really need to do is go grab my non-backlit portable because this is designed to work with the non-backlit model, where this one is, even though they're the same current. I don't know. So we're going to take this, go grab my non-backlit, grab the good battery, and we're going to make sure that it's stable of itself because this setup is not quite right. All right, so non-backlit portable hooked up. Let's go. Uh-oh. Spaghetti-o. Oh, no. Entropy strikes again. So, the logic board is dead on this one now. Yeah. We don't have a good hard drive anyways, but that doesn't matter. We've lost the logic board. Ah! Oh well. It is what it is. So, I mean, the AC adapter is clearly working. It's just, anyways. All right, well, what became a AC adapter repair video is now going to be a portable repair video. Wow, this is one that I recapped a long time ago because we have through-hole capacitors in here that I don't use like that anymore. So this was in the very beginning. Anyways, I think I see the problem. So if you look, there's like mouse droppings that got on the board. And you can see where it's corroded through the vias. I guarantee that's why it's not working. I bet that's why it's not working. So we have corrosion in the traces. There you go. I found the break. So the connection is open from pin 25, which is address line 12, back to the buffer, which is pin 18 over here. Where does that end up? Well, it starts here and ends up right there. So I bet if I clean that up, in fact, let me grab a, let's see here, hang on. In fact, let me grab some alcohol and clean that up, because I bet you gross. Because I bet that via right there is open. And it looks pretty crusty. Yeah, that'll do it. I bet it's open right there. So I drilled out that via and I put a patch wire in there. And guess what? Imagine that. It works now. Now I gotta reinstall that. There we go. Much better. Oh yeah. It helps when it works properly, because you know, things tend to not work so good when something gets on the board and eats the traces up. Alright, now that we're in here, we might as well take a look at some other stuff. So the next thing that happens to these, the next big thing that happens to these, is these rollers tend to degrade in the trackball. Yep, sure enough, this is no exception. See how yellow and wobulated they are? So all these have to be replaced. Now, all you need to replace these is go on eBay or Amazon or wherever. What the hell? And order up some 0.8 millimeter inner diameter tubing and just chop it. That's all you need to fix these. And we can take care of that problem with this. So I've got to pull this back out of here so I can work on it and fix that. But other than that, it's not too much else to go with this. Oh yeah, and the floppy drive situation. Now, unfortunately, with this one, the plastic is extremely busted up and brittle. There's cracks everywhere. It's falling apart. I've tried to glue this in the past, and then now the super glue came undone. It's brittle. And one is because it was stored poorly, and two, it was damaged in shipping. It took a big whack in the corner because this was broke off too. I think I got this thing dirt cheap 10 plus years ago, so that's why I bought it. Because I already knew what condition it was in when I bought it. So, anyways, not a big deal. I mean, everything is there. There's nothing missing besides the hard drive. But I have hard drives and hard drive brackets, but they're all bad, which is not a big deal because we can just put a blue SCSI Wi-Fi in there. And honestly, a blue SCSI Wi-Fi would be really good for a machine like this anyways, just because of what it is. Pretty much like that. I just grab a pair of snips and I cut these little pieces off from this tubing here, which should be close enough to match these. It's not going to be perfect because I can't cut this thing perfectly straight. And it will affect the performance a little bit, but it won't be as bad as like that. That right there is really, really bad. but it should be alright, I think, with these. So we'll put those in there, and that should solve our problem with the trackball. There. Now that the machine is actually fixed, God, wow, talk about a tangent. Got it fixed, so now I'm able to properly test the Sony power adapter. Okay, now I can wrap this video up. So, yeah, I thought I was going to make this a separate video, but I'm like, you know what? Why not? I just might as well just throw that in there because that's just how this stuff goes sometimes. So, anyways, if you enjoyed this video, don't forget to hit the like and subscribe and all of that fun stuff. If you have a comment, please feel free to leave one. Until next time, guys, thank you for watching.